Now we'll see how classes and functions go hand in hand. So as another example of a user defined type, I am going to define a class say called time that records the time of the day. So the class definition looks like this: class time, and I am taking object as its parameter. Okay. Represents the time of day. Attributes are hour, minute, second. Okay. So one more thing that you might be thinking what I'm doing in the class definition. This is a comment to know that what our class is going to do. So I'm going to create an object for the class time, and I'm going to name it time also, and I'm assigning it to my class, and I'm assigning the values of hour, minute and second myself. Let's say time dot hour equals to 11, time dot minute equals to 59, time dot second equals to 30. Okay, so now we have created the class time and assigned the attributes hour, minute and second according to our will. So now let's talk about something called pure functions and modifiers. So in the next few minutes I am going to write two functions that add time values. Okay, they demonstrate two different kind of function. One is pure function and another one is modifier, and they demonstrate a development plan which is very necessary for Python programming, and the plan is called prototype and patch, and it is a way of tackling complex problems by starting with simple prototypes and then gradually dealing with the complications. Okay, so here is a simple prototype of a function which adds time. So let's define a function say which adds time, and it takes two attributes, two parameters. Okay, so let me define it first and I'll explain it. So what this function do? It creates a new object for the time class, which is named, the object is named sum, and it initializes its attribute and returns a reference to the new object. So this is a pure function because it does not modify any of the objects, and does not modify any of the objects which are passed as arguments, and it has no effect like displaying a value or getting user input other than returning a value. Okay, to test this function I'll create two time objects. One is start and another is duration. The start contains start time of any movie, and like you say Monty Python and the Holy Grail, and duration contains the runtime of the movie, which is say 1 hour 35 minutes. So let's define the two objects for the class time. Okay, and start.r, say it's now 9:37, so I'm going to do that only 9. Start.minute, say 37, and start.second 0. And now I'm going to make another object which is duration, and duration.r equals to 1, and minutes are 35. Okay, and seconds are 0. Sorry, this is not minutes, it's minute. Okay, so now I'm calling the function add time and storing it in the variable done. And passing start and duration as the two objects. So now if I print time, okay, okay, so to print time I have created a function definition print time p, and taken as three attributes p.r, p.minute, p.second, and when I call print underscore time and pass done through it, it shows that t 10, 72 and 0. So the result 10, 72 and 0 is not what we were hoping for. So the problem is that this function does not deal with cases when the 6 seconds or minutes adds more than 60. So when such a thing happens, we need to carry the seconds to minutes and minutes to hour column. So here is the improved version of this function add time. So let's improve this function add time. Okay, before returning a sum, let's add some more conditions so that we can get the desired output. Sum dot, if sum dot second is greater than 60, or if say equals to greater than or equals to 60, then sum dot second minus equals to 60, and sum dot minute plus equals to 1. Okay, if sum dot minute is greater than equal to 60, sum dot minute minus equals to 60, and sum dot r plus equals to 1. Okay, then return sum. And this function is starting to get big, but it is correct. So we will see a shorter alternative of this function later. So now let's save this. Now let's call the function again. Sorry, first we have to call the add time function. Okay. So I have called the add time again, and now you can see that instead of 1072 it is now showing 1112, so which is correct. And now let's move forward to the topic called modifiers. Sometimes it is useful for a function to modify the objects as it gets as parameters. In that case, the changes are visible to the caller. Functions that work this way are called modifiers. Increment, which adds a given number of seconds to a time object, can be written naturally as a modifier. So here is a rough example. I am creating a function, say definition, increment, and two parameters, time dot second plus equals to seconds. Sorry, if time dot second greater than equal to 60, okay, then time dot second minus equals to 60, and time dot minute plus equals to 1. If time dot minute greater than equal to 60, time dot minute minus equals to 60, time dot r plus equals to 1. Okay. And the first line performs the basic operation, and the remainder deals with the special cases we saw before. Is this function correct? What happens if the parameter is much greater than 60? Parameter seconds is much greater than 60. In that case, it is not enough to carry once. We need to keep doing it until time dot second is less than 60. So one solution is to replace the if statement with the while statements. This will to make the function correct but not very efficient. So anything can be done with modifiers, and in fact some programming languages only allow pure functions. So there is some evidence that programs that use pure functions are faster to develop and less error prone than programs that use modifiers. But modifiers are convenient at sometimes, and functional programs tend to be less efficient. Okay. Earlier I was telling you about something called prototype and patch. So now let's discuss what is prototyping and what is planning. Uh, Till now I was demonstrating that for each function I wrote a prototype, then I performed the basic calculations and then tested it. And if I get any error, I patched it along the way. Okay. So this approach can be effective, especially if you do not have deep understanding of the problem. So uh, the incremental corrections that generate code that is unnecessarily complicated. So it is hard to know in these cases that if you have found all the errors or not, as the alternative way to do the effective programming is planned development, in which high level insight into the problem is made to make the programming easier. So in this case you can consider time object as a 3-digit number with base 60, and the second attribute is the ones column, the minute attribute is the 60s column, and the hour attribute is the 3600s column. So when we wrote add time and increment, we were effectively doing addition in base 60, which is why we had to carry from one column to the next. This observation suggests another approach to the whole problem. We can convert time objects to integers and then take advantage of the fact that computer knows how to do integer arithmetic. So here is a function that converts time to integers. So let's find the function which converts time to integer. Define time to integer. Okay, it takes time as its parameter, and let me define it first, then I'll explain to you. So I have defined the function time to integer conversion. So what I have done, I have known some time. I have converted it into minutes and seconds with the help of these expressions. So now I need to modify our add time function to make the original program shorter and much convenient. Okay. So this was our add time function. So let's change it. Okay. But before creating this add time function, I need to create one more function, which is integer to time conversion. So let me just create it. I have created an integer to time conversion function in which I have taken seconds as parameter, and I have created the object for the class time, and then I have used a function called divmod. It divides the first argument by the second argument and returns the quotient and remainder as a tuple. Okay, so in this case minutes are divided by second and the quotient and remainder. So if I divide 2 minutes by 60 seconds, so it will give me the a tuple with quotient and remainder, and same here for I have done hour and minute. So now let's create the add time function. And in this I am passing again those two parameters, and I am using the expressions seconds equal to time dot second, time to integer t1 and time to integer t2, and then I return integer to to time seconds. Okay, this version is shorter than original and easier to verify. So let's verify this. So I have to give the values to the this say start done equals to add time, start and duration, and then print time done. So you can see that it shows us the correct answer.